Hello, good day to all of you. Welcome back. There are two quality control methods for deep foundation prior to pouring the concrete. Number one is SHAPE, Shaft Area Profile Evaluator, and number two is SQUID, Shaft Quantitative Inspection Device. In this video, I will give you a brief background about these two quality control methods and also explain the procedure to conduct the test. Hi, I am Parthasarathy, founder and managing director, Sarathy Geotech and Engineering Services Private Limited. We are technical partners of Pile Dynamics Inc. USA and represent them in this part of the world to conduct training program and provide tech support. The drill shafts are not always an ideal cylinder. The irregularities will have an effect on the capacity, durability and performance. The Shaft Area Profile Evaluator or SHAPE is a very cost-effective quality control tool to evaluate the verticality of the deep foundation element, the shape of the pile borehole and also the volume of the pile borehole excavation, and this is applied to drill shafts, boreholes, the slurry walls, etc. What is this tool all about? The SHAPE tool has a geometry of about 460 mm diameter, 560 mm in height and 32 kilograms. This tool has 8 ultrasonic sensors embedded radially. When the voltage is applied, the piezoelectric element changes its geometry and releases the pressure waves. These pressure waves travel to the wet medium and hits the pile boundary wall and returns back. There are two sensors embedded at a known distance to calibrate the wave speed. So the test is performed by connecting the SHAPE device into the Kelly bar of a piling rig, or it can be also lowered into the borehole by using a winch arrangement. Please remember, the adapter that goes into the Kelly bar of the piling rig available on the site should be compatible. If you do not mobilize an appropriate size, there is going to be a huge embarrassment on the project site. Once the SHAPE tool is connected to the Kelly bar, it is centered over the pile borehole and is ready to be deployed into the borehole. The SHAPE will acquire the data at 1 scan per second and the drill stream progresses about 1 foot per second. As it goes down, the data is acquired and the output of the SHAPE will be the profile at each of those sensor locations and the volume of the SHAPE pile borehole, the eccentricity and the verticality. The shape of the borehole is sometimes very important in sediments like carbonate deposits which are prone to have cavities. And the shape defined volume will also resolve conflicts between the owner and the contractor, where the owner would have assumed a theoretical volume or the consumption of the concrete, while the actual consumption of the concrete could be entirely different than the assumed theoretical concrete. The SHAPE uses the ultrasonic sensors for a wet borehole, while it uses a LiDAR sensor for a dry hole. So in nutshell, it is a quick, cost-effective quality control tool. It provides a 360-degree 2D and 3D profile. It could be wire or wireless solutions. We actually commissioned the SHAPE tool in one of our projects, where the SHAPE is connected to the Kelly bar of the piling rig and ready to be deployed into the pile borehole. Output of the SHAPE will give the profile at the sensor location around all the sensors and the verticality and eccentricity of the profile. It was very successful, and the SHAPE has been specified in specifications of several federal highway in US, and I'm sure because of the nature of its application, this will also become very popular in this part of the world. The next quality control tool is SQUID or Shaft Quantitative Identification Device. So what does this SQUID do? The SQUID will quantitatively evaluate the contamination at the pile base, and this is very important for the piles which is deriving its capacity mostly from the bottom, that is your end bearing piles, and we do not want to have any contamination between the pile and the bearing stratum. where while conducting the load test, if there is a thick contamination, then the piles will experience large settlements and compromise on the bearing capacity. Like SHAPE, SQUID can also be connected to the caliber of the piling rig. In geometry, it has about 647 mm in diameter, 635 mm in height, and weigh about 180 kg. The squid has 3 penetrometer at the base, which is conical in shape, or it could be a flat base where the equivalent diameter is about 10 cm square, and there is also a retractable plate. When this is attached to the caliber of the piling rig and deployed into the pile borehole, the force from the caliber is released and cones will penetrate into the contaminated layer. The colored profile on the screen is the contamination. As it penetrates, there is a force measured and the retractable plate will measure the displacement. The squid assembly follows the THEORY-TERZAGHI'S general bearing capacity theory, where ultimate bearing capacity is equal to 1.3 times your undrained shear strength and the bearing capacity factor for a circular foundation. For a 10 cm square base area, for a 12 kilopascal and 100 kilopascal shear strength, the force required will be 0.09 kilonewton and 0.7 kilonewton. So what is this 0.09 and 0.7 kilonewton? This is a debris threshold and a probe threshold. The contamination is assumed to be a cohesive material. During concreting, if the undrained shear strength of this contaminated material is about 12 kilopascal, it is expected to be displaced during pouring the concrete. If the undrained shear strength of this contaminated material is more than 100 kilopascal, then it is treated as a natural materials. So there is a probe threshold and a debris threshold. So there is a force of 0.09 and 0.7 kilonewton. Therefore, the thickness of contamination at each of these probe location is defined as the difference in the displacement corresponding to a force of 0.7 kilonewton and 0.09 kilonewton. What you see on the screen is a force displacement curve. The thickness of the debris corresponding to each of those probe location will be the difference in the displacement corresponding to 0.7 kilonewton and 0.09 kilonewton, which has an average thickness of about 0.1 to 0.16 inch at these 3 probe locations. In fact, we commissioned the squid also in one of our metro project. You could see this squid is connected to the caliber, ready to be deployed into the pile borehole, and then it is lowered into the pile borehole. The caliber force is released and you could see the thickness of debris at center location is more than about 100 millimeter, an average of 3 probe location. For a large diameter pile, you have to do the test at multiple locations, perhaps one at the center and move to different quadrants. The average displacement at each of the locations for the 3 probes will be the average thickness of the contamination at that location. So what is the requirement? The requirement, some of the standards suggest that the thickness of contamination shall be less than half an inch. Where you are probing at multiple locations, more than 50% of the location should have a contamination less than half an inch, and the balance 50% shall not have a contamination thickness more than 38 millimeter. If it does, probably you may have to resort to cleaning the borehole by either airlifting, by bucket cleaning, or whatever the means, and redo the test to ensure that the thickness of contamination is minimum as per this prescribed limits, and then lower the reinforcement and pour the concrete. By doing so, you are ensuring that the thickness of contaminations is very minimal. While conducting the load test, the piles do not experience large settlements and the design capacity would be achieved. These 2 quality control tools, SHAPE and SQUID, are very powerful, and this has been specified in many projects in the West, and I am sure this will also be the new norm in this geography as one of the quality control tools prior to pouring the concrete, particularly for the drill shaft. So once concreting is done, then there are other methods to evaluate the integrity of deep foundation, which I will be talking in my subsequent video. So stay tuned for more information, and I will see you on my next video for the integrity evaluation. Until then, Happy learning. Thank you.